In this video we will see how to derive an expression for effective diameter based on three-wire method. So effective diameter is also called as pitch diameter or pitch diameter. First let's understand what is pitch diameter or effective diameter. Let's say that the threads are present over this cylindrical rod. Okay, so I am zooming in these threads and drawing it separately. So this distance between two consecutive crests is called a pitch. This line is called pitch line. So this pitch line actually bisects this axial thickness equally. Okay, likewise for the bottom portion of the thread I am zooming it like this. There will be another pitch line. The distance between these two pitch lines is called pitch diameter or effective diameter. Okay, so we will see how to measure pitch diameter or effective diameter using three-wire method. So as the name suggests, in three-wire method we will be using three wires of same diameter. Okay, as you can see in the picture in the right side, you can see two wires are placed in between the anvil and the thread, and one wire is placed in between the anvil and the thread. Okay, so these three wires are having same diameter. The diameter is d. Let us assume it is d. The two dimensional of the same picture is shown on the left side. Okay, whatever we get through this micrometer will be taken as m. We have placed this thread and three wires between the anvils of a micrometer. So now we will get one reading in the micrometer. That value is taken as m, and d is the diameter of the wire. Okay, and the same diagram you can see in the bottom. M is nothing but distance over the wires, and E, as you can see, the distance between two pitch lines, that is nothing but E. Okay, so we are interested to calculate only this E. We know this M value from micrometer reading. Okay, and we know the diameter of the wire. With this information we have to find out the effective diameter. Okay, so before going to the derivation, we should know some of the notations related to three-wire method. Okay, M is diameter over the wires, as said before. E is effective diameter. D, wire diameter. Okay, R, radius of wire. Okay, and then we have H. H is nothing but height of wire center above pitch line. You can see in the picture, this is the pitch line, this is the center of the wire. Okay, this height is small h. Okay, and capital H is depth of thread. This is the capital H, depth of thread. Okay, now from the micrometer reading we are calculating this M. Through relation we can write this M as E plus 2R plus 2H. Okay, You can see here m, this m distance can be found out by doing the summation of effective diameter plus wire diameter, sorry, the radius of the wire, this radius of the wire and this radius of the wire, okay, then 2h, 2 times the height of wire center above the pitch line. So that gives you the m value. In this we are interested to calculate E only, so it will be m minus 2r minus 2h. So m can be found out from the micrometer, r is the known value. If you know this h, we can easily find out the effective diameter. Okay, so in order to find out h, we have to do some derivation. We will see one by one how to get this h now. Okay, so in order to calculate h, from the diagram you can see h is nothing but AC. Okay, you can see AC is nothing but h. Okay, okay, AC, which in turn can be written as, from the diagram, it is AD minus CD. We can write AC as AD minus CD. I'll write that one, AD minus CD. If you are able to find AD and CD, we can easily find out H. Okay, now in order to find out AD, I am taking a right angle triangle ABD. Okay, I am considering this triangle ABD. So draw this, I am separately drawing this triangle also. This angle is theta by 2. Okay, this is A, this is B and this is D. Now from this triangle we know sine theta by 2 is nothing but opposite by hypotenuse. Opposite is AB, hypotenuse is AD. So AD will become AB by sine theta by 2. Okay, so that is nothing but 1 by sine theta is cosecant theta by 2 into AB. Okay, so from the diagram you can see what is AB. AB is nothing but the radius of the wire or diameter by 2. So I am writing AB as d by 2 cosecant theta by 2. Okay, so now we found out the relation for AD. So let us assume this is equation 1, this is equation 2. Okay, now from the equation 1 we have calculated AD. We are interested to calculate CD only now. Okay, so to calculate CD, consider triangle DEF. DEF, you can see DEF. This is F. Okay, so I'll consider DEF. DEF. This angle will be theta by 2. You can see here this angle is theta by 2, so this angle also will be theta by 2. Now from this triangle apply tan theta by 2 is nothing but DE by EF. Okay, DE by opposite by adjacent, that's why I have written DE by EF. Okay, so DE, what is DE? You can see here DE is nothing but this distance is pitch P, so half of it will be DE, so this distance will be nothing but pitch by 2, so it will be P by 2, okay, divided by H. EF is nothing but H, which is thread of depth of thread. You can see here H is nothing but EF. Okay, this H is nothing but EF, so I'm replacing it with h. Okay, p by 2 h. So now we will interchange the terms. H is nothing but p by 2 into 1 by tan theta by 2. So p by 2, 1 by tan will be cot theta by 2. Okay, so we have found out h is nothing but p by 2 cot theta by 2. Okay, from the equation 1 we are interested to find only CD. So what is CD? CD will be half of h. So just replace it with CD is nothing but h by 2, that is equal to p by 2 cot theta by 2 divided by 2. So it will become p by 4 cot theta by 2. Okay, let us assume this is equation 3, this is equation 4. Okay, now from equation 1 we know h is AD minus CD. From equation 2 we have found out what is AD. AD is nothing but d by 2 cosecant theta by 2 minus CD. CD just now we have found out, it is p by 4 cot theta by 2. Okay, so this is the value of h. Okay, if you remember in the first relation we have found out that m we already know from the micrometer reading, r is the wire diameter, h alone we are interested to find, that is also we have found out through the relation. Now let's substitute in this equation. E is equal to m minus 2r minus 2h. E is equal to m minus 2r minus 2h. Okay, so m minus 2r is nothing but diameter minus 2 times h is nothing but d by 2 cosecant theta by 2 minus p by 4 cot theta by 2. Okay, now we will interchange the terms. We'll find out, we'll take minus d multiply 2 inside the bracket, so it will become d cosecant theta by 2 plus p by 2 cot theta by 2. Just multiply these two. Now we'll take m plus p by 2 cot theta by 2. We'll take minus d common, so it will become 1 plus cosecant theta by 2. Okay, so this is the relation for effective diameter E. Okay, based on 3-wire method. In this equation we know what is m, which is obtained from the micrometer. P is nothing but pitch, theta by 2 is half of the thread angle, d is the diameter of the wire. So by substituting in this equation, after taking the micrometer reading, we can easily calculate the effective diameter. Okay, so this is how we have to derive the relation. This part we have to just enlarge it and draw one circle and name the radius and all these points D, F, theta by 2, H, capital H. After naming this, it will be easy for us to do the derivation. Okay, so in order to do this we need 3 diagrams, this one, second one, third one. So we have to draw the 3 diagrams to comfortably derive the effective diameter. Thank you.